So 64, we have a water fountain, so give me the information about this water fountain. We want the water to go to a height of 48 feet. Okay, and what we want is we want to find this VY initial. So we're just going to call the top of this water fountain to be the 0 height. So we'll say that the initial height of the water, when it's sprayed out of the water fountain, the initial height is 0 feet. Off with that. And the VY initial is what we're looking for. And we know that at some time t, we don't know the time, but we want this to get to a maximum height of 48 feet. And we also know that we're assuming she's building this on Earth, so g is 32 feet per second squared. Okay. And since we're looking for VY initial, and we have some s's, we're going to go back to our equation that s of t is equal to VY initial t minus 1/2 gt squared plus S0. Now, we know that at some time t, we want the height to be 48 feet. So we're going to plug in 48 for that. We don't know what VY initial is. That's what we're looking for. We don't know the time either. But if we plug in 1/2 of g is 16, and the height, the initial height is 0, we get this function. And the book says try, guess, and check, but there's a better way to do this. You could guess, okay, well, let's see, if t is 1, what would VY have to be? If t is 2, what would VY have to be? And we're trying to find the minimum velocity that you can launch it. So we want the smallest velocity that you can launch this water at in order to get to 48 feet. As soon as you see the word min, you should be thinking, oh, this is a function that's going to have a minimum in it. So we have this function here, 48 equals VY initial t minus 16t squared. So if I was to graph, let's rearrange this and graph VY initial as a function of the time. That's going to give me a graph with the minimum on it. So we have to rearrange this equation so that it looks like y equals, or VY initial equals. So we get VY initial is going to equal 48 plus 16t squared and divide by t. So I can do those steps separately, but that's rearranging that equation. I'll do the steps up here so that you can see what. So we have 48 equals VY initial t minus 16t squared. So we're going to add the 16t squared to both sides. And you get 48 plus 16t squared equals VY initial t. Divide both sides by t, and you end up with this function down here. Okay? So we get VY initial equals 48 over t plus 16t. Now, if you plug that in to your calculator with VY being the y-axis and t being the x-axis, I'm going to go to a new slide for a sec here. So we have VY initial is equal to 48 over t plus 16 times t. That's y equals 48 over x. This is what you plug into your calculator, and you're going to get a graph that has a minimum. You're going to get a minimum value for your VY initial right here. So whatever that value is, that's the smallest velocity that you can get and still reach 48 feet. That's a better way to solve that problem than guess and check. So once you get this graph, right, you're going to see a minimum there, so you're going to have to fool around with your time. It's not going to take much time. There's also a part of this graph down here, which we don't care about. That's negative time. But once you get that, you're going to graph that on your homework, and you're just going to point to that. The minimum VY initial value is going to be some number. And that's the solution. You don't have to do it. That's why the graphing calculator makes these go fast. All right, so 61 is the one where you get somebody in the stands at some stadium, and it's 83 feet he's in, standing here.
Yeah, 83 feet above.
His legs are detached from him. And he throws this baseball vertically upward. Does it say the velocity he throws it at?
Is the
90?
vertical velocity of 92 feet per second.
Okay, so he throws that upward at 92 feet per second, and he throws it from this initial height of 83 feet, is that right?
Yes.
Okay, so he's standing in the stands, this is a very funny looking person, but throws the ball up 92 feet per second. And the question says, maximum height, right?
Yes.
So it says find the maximum height. Find S at the maximum height. So we know, oh, we should see some kind of curve where there's a max on it, right? And then it says, how long does it take to hit the ground? So it's gonna go up, and then it's gonna come right back down past him. And we wanna know, it's gonna hit the ground too. So if I was to graph a position as a function of time, the height of this ball, it's gonna get thrown from 83 feet. It's gonna go up and down. It's gonna hit the 0 height level at some time. That's what the graph should look like. So how do we get what that graph looks like? We need the S of t function. So we know S of t is equal to Vy initial t minus 1/2 gt squared plus S0. All right, so what is the 83 feet? Which variable is at 83 feet? All right, so we're gonna take this 83 feet, that's the initial height, the Vy initial is 92, and we're just gonna plug these things into our function. S of t equals 92t minus 16t squared plus 83. There's your function. If you graph that function, you should get something that looks like that, and you can pick out the maximum height. That's gonna be there. You can pick out how long it takes to hit the ground. That's gonna be the time at that point, right? And then the last part of this problem says, what's the velocity when it hits the ground? So the velocity when it hits the ground, you're gonna take this time, when your S function says that the ball's at 0, and you're gonna plug that in. You're gonna plug that into the equation that we have for the velocity, which is, Vy initial minus g times t. So once you know the time, you can plug into this equation to find the velocity that the ball is going when it hits the ground.